Hey, welcome back. This tip of the week should be pretty short. This week we're just going to talk about links. We're going to talk about hard links and symbolic links and the difference and how this is set up. So it shouldn't take a lot of time. We have a couple series coming up related to file system permissions and SE Linux. They're going to take a while, but this should be a pretty quick one. So here on the test objectives, if I go ahead and just search on links, you'll see here that we have this test objective to create hard and soft links. So we're just going to kind of define what each of those is, and then go out and create some links, give you some demos there. So go ahead and bring up the screen here. Before we actually start looking at the vocational side of things, let's just go ahead and talk about hard links versus soft links here. So let's start out with the hard link. So when we talk about a hard link, let's start our conversation by generally sort of discussing, what a file system is. And so, a file system is an allocated area of storage where that gets divided into, units. We talk about blocks of data and things like that. All right, so that's where we actually store the information, about our files. Okay? And then every file system has some sort of allocation table. Okay. There's different ways that the information is stored, bitmaps, binary trees, there's different names, FAT, directory entry table, and things like that. But there's some type of allocation table. And so the allocation table, and keeping things sort of generic and simple, really contains the metadata, the information about the files on the system. And so the file system or the metadata will point to, blocks, okay, where that file is stored, where it is, allocated. And every file is assigned, a unique identifier. So every file has this, what's called an inode value. Okay. So whether we're talking about, hard links or soft links, right now we're just kind of talking about files and file systems and how every file is unique, assigned this unique identifier that we call an inode. Okay. Well, a hard link is really an additional pointer to the same inode. Okay, so a hard link is really going to point to the exact same blocks of storage on the file system. So when I create a hard link to a file, really what I'm doing is I'm just creating, another pointer, to the, did that pointer backward, to the inode value. Or the actual file on the file system. And so it makes sense that when we create hard links, one of the things that we always need to remember is that they cannot span file systems. Okay. All right, so when we're creating a hard link, it has to be within the same file system. We try to span a hard link across a file system, we're going to get this illegal reference error, or cross-link error, I guess is the actual official error that we get, that it cannot create the link. All right, so that's a hard link. Okay, now a soft link, go ahead and define that here. So a soft link really is I guess people liken it to a shortcut, like a shortcut in the Windows environment. So just think of it as a shortcut, and a soft link has its own inode value. It is its own separate reference. Okay, so it creates a shortcut to a file or a directory as opposed to just pointing to the same file. So a shortcut or a soft link can span file systems, and I'll demo that in a second and sort of explain what I mean by that. So we're going to look at hard links first, and then we'll take a look at soft links, and hopefully you'll have the information you need to answer any potential question that you might see on the exam. All right, so hopefully I'm still logged in here to my box. The first thing I'm going to do is I'm going to make a directory called links, and I'll go ahead and change directories into my links directory. All right, so right now I just have an empty directory. So I'm going to go ahead and create a file. Okay. So if I say touch file1 and then do a long listing there, you'll see that we now have file 1 on our system. Now, creating links is pretty straightforward. If I just say ln, and then I'm going to go ahead and link to file 1, and we're just going to go ahead and call this link 1. Okay. Now, again, if I do a long listing, take a look here. Okay. What do we notice that's different? Well, this value increased. This value went from 1 to 2. Okay. And if I create another link real quickly, so I'll just go ahead and create link 2 here, and then again do my listing, you'll see that that number incremented again. Okay, 1, 2, 3. So that number represents the link count. Okay, so how many hard links? So what I've created is a hard link, and if I do an ls minus, let's do li, I will show me the inode values. Okay, and you'll see that those 3 files there, okay, have the exact same inode value. Okay, so if I were to change one of those files, for example, if let's just go ahead and open up file 1 here, and we'll add some text. We'll say hello world. If I take a look at, for example, cat link 2, because it really is pointing to the exact same file on the file system, it says it, and it concatenates the exact same text that I just entered in when I did a edit for file 1. Okay, so they do represent the exact same file. If I modify link 2, my name, and now if I take a look at the contents of file 1, I'll see my name is there. Okay, because again, they do point to the exact same file. Okay, if I remove one of those, for example, if I remove, let's say link 2, and then I do my long listing, you'll see that my link count went down to 2, but all my data is still there, right? If I cat file 1 or link 1, there's all of my data. So that is a hard link. Now, I'm gonna go ahead and SU out to root here. And if I do an ls block, you'll see here that I've basically got a couple different file systems. I've got a file system out here at root boot, and then I also have, a file system at root, and then my swap. So if I change directories here to boot, okay, so now I'm in a different file system, and I try to create a link to, let's just say file 1. I'll call it link 2. And you'll see here it said failed to create hard link to home student links file 1 invalid cross device link. Okay, because they point to the same inode value, I can't create a link in a different file system with a hard link. All right, so now let's take a look at symbolic links. So I'm going to basically do the same thing, except this time let's do a long listing here. So we've got our file and our link count is at 2. I'm going to do an ls minus s, okay, and then I'm going to link to file 1, and we'll go ahead and call this, actually I just love typing in slink, so we'll call it slink 1. Now when I do a long listing, okay, you'll see that it's represented in teal there, and it's pointing to file 1. It didn't change my link count. The symbolic link has an identifier that it is a symbolic link. You see the little L up there. And so if I cat the file, if I say cat slink, I get that same type of behavior. It's going to actually give me the contents of the file that the link references, but it is not the same thing as a hard link. If I do an ls minus li, what you'll notice here is that the inode value over here for the symbolic link is different than the inode value for the top 2 there, which would be the hard links there. Because it is, it's separate entity. It is very much a shortcut, and it does point to a particular file. If I, for example, remove file 1, is my content still there? Is my data still there? Well, link 1's still there, right? And that's a hard link. So if I cat link 1, my data is still present. But if I try to cat S-link one, you'll see no such file or directory. So because the symbolic link pointed specifically to file 1, when I created or when I removed file 1, I broke that link. Okay. Now, if I create a hard link, we'll recreate it for link 1 to file 1, and then again do my long listing, you'll see that that fixes my link. And the other thing is that these symbolic links, can span file systems. So go back to root for a second here. And so as root, I'm going to change directories to boot. And then this time I'm going to say lm, but I'm going to create a symbolic or a soft link to home, student, links, and then file 1. And I'll go ahead and call it slink2. Okay. No such error. If I do a listing on that, so I'll do a long listing on slink2. There it is. We can see it points back to home, student, links, file 1. If I cat it, I'm going to get the contents of that file. Okay. So symbolic links, and you're much more likely to see symbolic links on the system than you are hard links. If we talk, for example, if we're talking about like system D, and I go and change directories out to Etsy, system D system, do an ls here, you'll see that I've got a bunch of symbolic links there. And if we do an ls on the multi-user target wants, for example, so I'll do a long listing on multi-user target wants, and you'll see those are just a bunch of symbolic links back to the services files out there in user lab. Okay. So in reality, you're much more likely to see soft links being utilized by the system, but the objectives say that they want us to understand and be able to work with both hard and soft links. So hopefully that helps, and we'll see you later.